Good morning, everybody. How is everybody doing today? If this is one of the first times you've joined us on one of these webinars, there's a chat box that you are able to go in and post your questions. Dan will be fielding all those questions. So feel free to jump in there. Go ahead and find that chat button and everybody say hello, Dan, in there, so we know you found it and get the conversation going. This month's webinar is going to be on GD&T, which I'm really excited to get into. Got 43 people with us today, and it's probably going to grow here as people start joining on, but we're going to jump into it because I know we're all very busy. So first thing that I wanted to talk about on this month's webinar was the May webinar, a little quick review in case anybody missed it or wanted to hear more about it, and some of the stuff pertains to GD&T and what MicroView can do with GD&T. So two of the main topics that we talked about in the May webinar was offline programming and common and uncommon systems. And the systems part is really going to play into setting up datum structures for GD&T and getting everything set up so you are reporting accurate GD&T results when you're measuring your parts. So a little thing about offline programming, you can program off CAD files, and this is really helpful for when you're working from home. In times like these, we've heard a lot that have kind of split schedules, half from home, half in the office on your machine. So you're able to program from your laptop with CAD files and be able to set up pretty decent programs that you're able to, when you get into the office, be able to put it on your machine and actually start measuring physical parts. When you don't have physical parts, but say you have a new mold coming down the line and you have CAD files that are available, you can start programming your parts before you even start making the parts. So you're a jump ahead, quality is ahead of production, so you're able to start going there. And then also, we've been seeing a lot of people creating custom fixtures for their parts. So while that's being designed and built, you can start programming off of that. It increases productivity without machine downtime. If you guys are running your MicroView, 24/7, and it's hard to get on there and actually program when you're just trying to measure parts all the time, you're able to program and then sneak in there, put the program into use, and get going there. And it's very cost effective. It is a fraction of the cost of an actual machine. So if you have, your actual machine in the quality lab, you can program off, like I said, on your laptop and for a fraction of the cost. So email sales or training, and we can talk to you more about that if you're interested in that. We saw a lot of interest after the May webinar. So one of the other things we talked about in the May webinar was common and uncommon systems. These are very important, like I said, to set up datum structures. So I want to just go through a couple of them that we touched on in May. This one, very common, line, intersection point between those two lines and putting a focus point on top of your part. On this print, we're measuring a line on datum A, a line on datum B, and putting a focus point to set our Z height. Another one was circle line focus point. These systems here, these common systems are very good, even if they're not necessarily your datum structure. If you're running a semi-automated program, these are simple systems to get your program up and running, so the rest of the program is automated. Another common one is circle focus point. Now, this one confuses a few people when I talk about it because they don't see where the alignment comes into. But if you click line and click those two circles in Inspect, it actually creates a line between the two center points that you can skew to. So your origin would be one circle, and you'd be skewing between the two diameters. One of the uncommon systems that we talked about was creating a gap on the sides of the part and creating a bisect line in the middle of those, intersecting it with another edge on the part, and then doing your focus point. So I'd put my origin to the intersection point, and I'd skew to the bisect line in the center of the part, and I put my origin of Z to the focus point. So just a quick review of the May webinar. We're trying to do these monthly, and actually after this webinar, I'm going to send out a survey. I would love to hear from you guys what things you're having difficulty with and what you guys would like to see on the webinars. A little feedback there. So this month's webinar topics, we got a lot of feedback from the last couple ones that we've done, is that a lot want to hear about GD&T. This webinar is going to be a very, very condensed version of our Advanced 2 class that we teach that really dives deep into the GD&T capabilities of MicroView's InSpec software. We're going to give you some tips and tricks, the tools that we recommend using, tools to try to stay away from that aren't that very accurate when you're trying to measure GD&T. So we're going to do a GD&T overview. We're not going to go dive deep into the specifics of each symbol and what it's actually controlling. I mainly want to show you how to measure them in InSpec, and we would love to follow up with you afterwards. And any features, GD&T callouts that you guys are having difficulty with, let us assist you in that. We're going to talk about system importance. We're going to talk about using vision and touch probe to measure GD&T, and then certain ways that InSpec exports GD&T into Excel formats and how the MicroView InSpec reporting works. I want to show you a couple of things in there just to kind of help you guys out, because sometimes it takes longer to report and fill out your inspection report than actually measuring the part. So any way that you can speed up that process will help all your overall productivity. So again, make sure to join the chat. I see a lot of people said hello to Dan. Any questions in there or anything that you guys want to, topics that you guys want us to follow up on, jump in there. So I just want to show you guys a little video of quickly how quick MicroView can measure GD&T, and I'll try to talk through it as quick as I can while it's measuring. So here, it starts out by measuring 2 quick intersection or lines for an intersection point to get my program up and running. And now it was measuring the datum structures on the side of the part A and B. Now I'm using area focus to measure the top plane on top of the surface for my datum C on this part. And then here, quickly, it's measuring the outside diameter on that post and an edge for angularity. And if you guys see up in the log view, it's measuring all those lines and reporting straightness. We got some straightness that's out on those points, probably because the flash that was on the part. And then right then it is able to export the data to a PDF that MicroView has in its software. If you don't know where to find this, you can go to File Reporting, and there's many different options on how this MicroView report looks. It's nice because it has the colored graphs on there, what's in, what's out, how far out of tolerance it is, where it is in the tolerance range. And when you take time to name all your features and do the exporting, this report looks real nice. You got your schematic window. So just a real quick end result of measuring GD&T and reporting it. So let's jump into GD&T and how do we get there. A couple of things I want to talk about. All form tolerance callouts will require more than minimum points it takes to measure that. So for example, a line takes 2 points, you need 3. Circle takes 3 points, so you need 4 points. I'm going to show you more tools to take more than the minimum requirements to really accurately report your GD&T. Any tools that are mentioned that I talk about in this webinar, because like I said, this is kind of a condensed version of Advanced 2 class. You can go back to your basic training manual and start in chapter 2, and there's literally a page for every single tool and icon in the software. If you don't have a basic training manual or haven't been through our formal training, email us and we can help you out there. So the first one is, the first 4 symbols that we're going to talk about is straightness, flatness, circularity, and cylindricity. And then we're going to skip over profile today, just because it's a little more complicated. I don't want to take up too much time today on talking about profile. But if you guys are having difficult profile call-outs and you don't know how to measure them, again, email us. We want to help you out. That's why we're doing these webinars. We want to support you guys measuring your parts. We're going to talk about perpendicularity, angularity, parallelism. We're going to talk about true position, concentricity. One thing I want to mention is that MicroView does not support symmetry. We have a couple customers that have symmetry on their parts, and we run those on the CMM. So if you guys have any parts that are requiring symmetry and don't have a way to measure them, send us a print, and we could figure out how we'll able to report that for you. And if you send it to us in our lab, we're able to throw it on our CMM that we're running, CMM Manager, and then we'll be able to get your results. We also are going to skip over runout. If you guys are dealing with a lot of runout callouts, again, send us a print and we can help you out. Figure out how you guys can measure it on your MicroView, or if you send it to us, we're here for support. So some of the basics and common icons that we're going to talk about when reporting and measuring GD&T. First thing I want to talk about, how do we tolerance it? So when you measure a diameter, if you right click, you'll find the tolerance option. You also can hit F3. You guys are probably super familiar with this. Any GD&T that is able to be reported for certain features, so like a line, you're able to measure straightness, perpendicularity, parallelism. All the options are here for the tabs, and all these we'll talk about, individually for each call out, if it's related to a datum or not. For all these form tolerances, they're not related to a datum. So all you do is put your tolerance in there and it calculates the deviation for you. And you see all the different tabs here, they're all there. MicroView Inspec is really nice because it's a lot of icon based and user friendly, just symbols, find what you're looking for. Some of the other common things that you'll see with all the GD&T is in your result summary window. Once you tolerance whatever you're trying to measure and report, it'll pop up on the result summary. So for instance, this one was straightness. It popped up the results there. One of the really cool things about Inspec is when you measure a line or a diameter or whatever it might be, down in the points view, depending on your monitor resolution, it'll either be in the lower left-hand corner or it'll be next to the in the result summary tabs area, you'll see the points view. When you measure it, you'll see, I use an F-scan line for this, and it plots all those points on that edge, and you'll see pink highlighted points on there, and those are the max and the minimum values that are for that certain feature. You'll also see this light blue guard band around that. So for straightness, it puts that guard band around that F-scan line, and all the points fit within that guard band, and that's your tolerance. If any of the points fall out of that guard band tolerance, you'll see them go red. Now, if you see red, check your part, see if there's flash, if there's a burr, or your line, your edge might just not be straight, and that's where it's out of straightness. All right, so this is kind of how I wanted to format each symbol, kind of talk about a recommended tool, if it's relative to a datum, minimum points, and I kind of threw in a second option there of what you could use to measure certain GD&T. So jumping in for the first one, straightness, it's not relative to a datum, it's to itself. And it takes a minimum of 3 points, because then you get that deviation of a perfect straight line between 2 points. You put that third one in, and then you start getting your deviation. Our recommended tool is using the F-scan line. So I would click line, and I would click more inputs, and an F-scan line, because I don't want to just take one F-scan line. If it's, a very long edge on the part, you don't want to just take one line to report straightness. You want to take that whole edge across that whole call out that it's asking for to be able to truly report your straightness on that edge. Another second option that you could use is best edge with more inputs. The reason that I do not like using best edge when I'm measuring straightness is because you can select where you put those best edge points. And if we're measuring a part for straightness, we don't want to, find where the line isn't straight. So we want to accurately report this so we know that when we're sending parts out, we're confident that we're reporting the right numbers on there. The next one I want to talk about is flatness. Flatness is just like straightness. It's not relative to a datum. It's to itself. It requires a minimum of 4 points. 3 points makes a perfect plane. That fourth one gives it deviation. My recommended tool, depending on the surface of your part, if it's very pitty or has a lot of reflection, you want to be careful with area focus, but area focus is going to take as many focus points as it can within this box. You can see the pink crosshairs in the zoomed in version. It's putting a focus point every single spot there. So when you're able to take multiple area focuses across your whole plane, this plane, for example, has over 200 points plotted across the whole plane. So I know I'm accurately reporting what my flatness of that feature is. One thing too is that we put a note in here that not to confuse flatness with a level. Sometimes when you're measuring a part, most of the time the datum that is the plane is going to be controlled by flatness, and then other features are controlled off of that. So just be really careful with that. And here too, you can see that flatness, it gives you the deviation, the points view. I really like the points view if I'm researching why a part's out. I dive into there and see where where my deviation is going. A lot of some of these prototype shops that we work with, they're really diving deep into the points view because they're figuring out really what the shape of the part actually is. Second option to measure flatness is also focus points. So you can take just individual focus points around your part. That takes a little more work and more time if you want to get a lot of focus points on there. The area focus is able to just throw tons of focus points on there and get you the results. Another note is if your machine does have touch probe on it, it's also a great option. You got to be careful with the size of the stylized ruby ball that you're using, depending on how your feature is. And I got actually a couple videos in this presentation of the touch probe at work and how it helps us out measuring GD&T. So we'll see some of those. So yeah, so I would click plane, more inputs, and area focus, and go around my feature and get all that data that we need. Circularity is we're controlling the form of a circle that is perpendicular to a plane. So this is controlling, making sure that the diameter isn't oval shaped, isn't egg shaped. So here, if I can see the whole diameter in my camera window, I'm able to use the F-scan circle, and then that's able to put 100 points around the diameter and really get the true shape of that diameter when we report circularity. If you're not able to see the whole diameter in your camera window, if you go circle, more inputs, F-scan arc, like I did here, if you look at the red arrows, you plot a bunch of F-scan arcs around that diameter and you get the whole feature of it. You really want to make sure that you put points around that whole diameter when you're measuring circularity, because if you miss, for example, down here at the kind of lower right-hand corner of the diameter, you'll see that that's where the points are furthest out of the diameter. And if you miss those points, your circularity readings will be off because you're not getting some of the worst deviation that you're seeing in that diameter. Especially, this is controlling something, a mating part going into it. if those points that are more into the inner of the diameter, inside of the diameter, and those obstruct the mating part going in there, you're going to have some real trouble when you ship your parts out. So make sure you get the whole surface of that diameter on there. Touch probe is also a great option for this too. You're able to take, especially with the advanced features of rotate and, when we talk about cylindricity, translating it down in Z, take as many points as you can. You can take 1 point with the touch probe, rotate every 10 degrees, and you really get the true shape of that diameter there. So here's one of the videos for touch probe. Here I was measuring cylindricity. So I bring the touch probe over, I took 1 point on there, and I was able to rotate every, I believe it was 20 degrees. I do a lot of points around the cylinder when I rotate, because you got to be careful on the outside diameter of it. It's gonna, without move through points, it's gonna crash into that cylinder. So you could even do every 10 degrees and take 36 points around that diameter, and it'll safely move around that diameter. So here I just had it go, and I took 1 point off the cylinder, and then I told it to rotate, and then I took that circle and I translated it down in Z, and I was able to measure this cylinder. I wouldn't be able to measure that cylinder with vision. So if you're seeing features like this on your parts, instead of flipping it sideways and only seeing half the cylinder on there, touch probe might be a good option to get onto your microview. All automated microview machines are able to have the touch probe attachment added onto it. So let us know if this is something you're seeing more and more, and we'll be able to help you out there. So here with cylindricity, for an ID cylinder, it's not relative to a datum. Minimum points is 5, but we recommend 6 or more. Anytime that I'm taking a cylinder measurement or any circular measurement, I'm taking at least 6 to 8 points. If it's really tight tolerances, you want to take 10 points to really get the true shape of that diameter in that cylinder. For an ID, you're not able to see the whole diameter with vision, so you need touch probe. There's really not a second option that I would recommend if you're reporting cylindricity and having to measure it. For an OD cylinder, you can use vision, but I want to say that if you have the cylinder on its side, you're only getting half of the cylinder on there, and it may not be accepted by your customer, and you're not getting the whole form of that cylinder. So here, you actually won't see any guard band on the cylinder when you're doing cylindricity, but you'll be able to see all the green points that are within tolerance, and you'll see the red points are the ones that are out of tolerance. And this helps you figure out where your diameter, your cylinder is out of tolerance with cylindricity. And, check out your part. Some of the first things to check out is there a burr in there that if you're using touch probe that it's hitting off on? Is your touch probe ruby ball not large enough to get inside that? And, kind of do those things before reporting that it's out. Cylindricity is one of the GD&T callouts that, it's controlling circularity, but also straightness at the same time. So it's this cylinder, I took 2 circles diameters around the cylinder. Depending on how large your cylinder is, I recommend taking, 3 to 4 diameters around that cylinder, just in case you're not getting, if you're just taking the ends of the cylinder and you're not getting the middle, that might be where it's curved. So really be careful with that. All right, so the second section of GD&T symbols that we're going to talk about are perpendicularity, angularity, parallelism, true position, and concentricity. And I have some, and these are all actually relative to your primary datum and a reference frame. Sometimes you'll see parallelism to no datum, but most of the time it's going to be this edge to another datum. So let's talk about perpendicularity first. Here on our blueprint, we see the perpendicularity symbol, and it's referencing datum B. From the right side to datum B. So for 2D features, dependent, I put on here minimum points dependent on features. So if it's a line, like I said, you need more than 3 points on there. If it's a cylinder, more than 6 points on there. You can use F-scan tools for 2D features if it's the outside features. 3D features, you really want to use that touch probe. The example that I have here, we have, you notice here on my reference feature, when you measure your features and then go to tolerance them, and I click my perpendicularity tab, it says reference feature. So whatever feature that I'm tolerancing is going to need to reference a feature. When I'm programming in MicroView in spec, I rename my datums because when you get to this tolerance box and you click down this drop-down menu, it's not going to tell you, you're not able to click in the schematic window what feature you want to reference. So easily in my drop-down menu, I see datum A, I can click it, tolerance it, and be done with it, and not have to click out of the tolerance box, go find out what feature it is, go back, and do that all over again. So here is an example of if I want to do perpendicularity on a side feature. You see in the picture on the top right corner, I have that plane and I have a cylinder within that side feature. And since instead of writing a program that has to flip apart a bunch of times, MicroView is able to have a star probe programmed into your touch probe rack and come and measure that. So here's a little video of the star probe at work. The first thing I did was I measured the camera, and vision is measuring the top plane for some of the other features. And then I'm able to go grab a straight probe and come measure the top plane for some other features. So when you're programming, especially with touch probe, you know, we talked about, I believe in one of the earlier webinars, was really battle planning when you're programming a part. You want to use as much vision as possible first, and then move to your touch probes. And whatever touch probe you're going to use, go and get all the features with that certain touch probe to save time on the machine going back to the probe rack, grabbing the probe, moving, going back, you know what I mean? So this, you can see the star probe is able to come down on the side of that part and measure that cylinder, and we're able to report perpendicularity on a feature that isn't visible from vision or a straight probe. And those styli that go on the star probe, you can add many different sizes, lengths, whatever you guys need. We have been building our styli library, and we recommend you guys do the same because you guys are going to come across parts that may need a different size, you know, ruby ball or length on the styli. Instead of having downtime waiting for those to come in, start building up your probe library while you can. So when those features come up, you're able to just jump into it and program onto there. One thing that I want to mention with the star probe is you see in the top left corner picture that I have there, you see the styli B is highlighted. I still forget to click sometimes if I'm using that styli. You need to tell inspect which styli side of that star probe that you're using, so it knows, you know, where it's triggering off on, and put that in there. Very common mistake. I still forget to sometimes when I'm programming and have to go back. So it's just a little tip there. Let's talk about angularity. So here's the angularity call out on there. It's the top left edge in relation to datum B. Now here is one that needs a basic dimension too. And so this angularity call out is referencing that 45 degrees there. When GD&T symbols and the call outs aren't relative to a datum, no basics are needed. now that we're starting to reference datums, we need basic dimensions on there. On this print, the 45 degrees, most of the time you'll see the basic dimensions have like a box around them. This one doesn't. So sometimes there's a little investigative work. Again, like I was talking about the battle planning, you really want to, before even measuring the part, looking at your print, what the GD&T is asking for, what basic dimensions it's meeting, and making sure that it's all there. There's times that I've seen true position callouts, which we'll get to in a little while, that don't have the basic dimensions too. They got left off the print. So then we get to go talk to engineering, find out what it is. If you have the CAD file available, we're able to help you out there too. So before even measuring the part, make sure that when you're looking at the GD&T symbols and the callouts that you have all the dimensions that you need. And some of them, like if you look on this print here, the dimensions 4 and 5, they're building the distances on there. So sometimes you got to do a little math too. So here, angularity, it's relative to a datum. Minimum points dependent on the features, like we talked about in the previous slides. You know, how many points you need for certain features. Requires a basic angle. And then same thing with like perpendicularity is that when we right click or hit F3 for the tolerance box, it's going to ask for a reference feature. And you can see here my drop down menu, I got datum A and datum B that I'm able to select. And then here in the angularity tolerance tab, this is where you put that basic dimension, that reference angle into. And that'll calculate it for you. Nice that you don't have to do any of the math, you don't have to do any of the calculations, it's all there for you. Parallelism, a couple different styles of parallelism that you'll see. 2D features, you know, for example, this sample slide that we've seen a ton of could be from one side to the opposite side. There's no call out on this print, but this would be parallelism from the right side to datum A. And then we're able to use F-scan lines across those edges and be able to report that. So this is a 2D feature, same thing. You right click, tolerance, F3 tolerance. So I would hit my line icon, more inputs, F-scan line, get all those edges and be able to report it from there. And this one, it's just looking at the other features, so there's no basic dimensions here. It's comparing line to line on there, so none needed here. For 3D features, you can use, I'm going to show you an example with the touch probe of measuring some planes. You also can use vision to measure the two planes. So here, the touch probe comes and measures that top plane, and it's going to reference datum C, which is the other plane. Depending on how your customer may be measuring the parts or your supplier is measuring the parts, if they're using touch probe, you use touch probe. If they're using vision, you can use vision, just so your numbers correlate on there. We have one customer that their supplier is only as a CMM, no vision, it's only touch probe. So they are building their styli and touch probe library to be able to compare apples to apples with their reporting on there. So here with parallelism, we have our two planes that we're able to compare. Like I said earlier, generally datum A, here the plane would be controlled by flatness, and then the other surface can be controlled by parallelism. So then everything is controlled in your process, and when we're measuring and reporting all of it, we know that the parts are good or hopefully not bad. But parallelism controls two features that should have minimum to no angle on them. So depending on how the function of the part is, you know, it's making sure that basically both sides are straight with each other, and you're good to go there. Same thing, all the tolerance boxes that we've been talking about, that reference feature, I labeled it datum C, so I'm able just to grab that plane. You know, the more lines and planes that you measure, that renaming is so key to just quick programming. And that's actually, we were talking about next month's webinar, is that it's going to be on, you know, things to expedite your programming and your reporting and inspection process, you know, all little, not necessarily hidden features in Inspect, but things that you either forget about or didn't know was there because training was 4 years ago and you never used it. We're going to be talking about all those type of things, renaming, auto-generating drive points, and all these kind of things to make your inspection process quicker. All right, so here is the, you know, true position. One of the more, not necessarily complicated callouts in GD&T, but it takes a little more work than measuring, you know, 1 or 2 features on a part. So there's generally 3 types of true position callouts. There'll be true position regardless of feature size, RFS. So if you see in this example, you have the true position symbol, you have a diameter with a tolerance on there, and what datums it's referencing. There's no material modifiers that we'll talk about here in a second. So this is regardless of feature size. No bonus tolerances get applied to it on there, which we'll talk about. A couple of things that you'd have to do to set up, make sure that you measured your datums correctly. So when we were talking about, you know, your common systems and your uncommon systems, you got to make sure that those systems are measured correctly. And then because the basic dimensions that we're going to talk about relate to those datums. So if your system isn't set up correctly on your program, your basic dimensions aren't going to make sense. So that was regardless of feature size. The next one is LMC, least material condition, and you can see the L that's in the tolerance box gives us that modifier that later on we'll be able to apply bonus tolerance to the part depending on the size of your diameter. And then max material condition. And again, you'll see the M on there, and this will notify you that you're able to set that modifier on there and get your bonus tolerance. So how do we do all that? Here on regardless of feature size, we got to look for our basic dimensions. We got to look for our datums that we set up, and, you know, we set up our system correctly. When we measure all this, we have a little step process here and how to measure all that. When we right-click that diameter and come to our tolerance box, you'll see the true position symbol. Since this is RFS, we don't get any bonus tolerance, so we'll put in our 2 basic dimensions, our X and Y basic dimensions, and then it calculates the true position for you. Couple things to look out for basic dimensions. Like I said in the other blueprint of our sample slide, sometimes it has building tolerances on there. So you'll see maybe halfway it'll say 2 inches and then it'll say 3 inches to build that whole basic dimension. So sometimes you need to add all that. For material conditions, we're able to put in our diameter size and the nominal and put in our tolerances here, and it does the calculation for your bonus tolerance that you get. One thing to pay attention to is if it's a through hole or a post, because that matters if it's going to be larger or smaller. If you have less material in a through hole, that means that the diameter is going to be larger. If you have a less material for a post, it's going to be smaller, and it needs to know those features when it's doing the calculations for you. If you are able to use any of these modifiers on the print and you're reporting it, make sure that you report that that bonus tolerance on top of it, just so there's no confusion when you send the reports to your customer or supplier where you got that bonus tolerance on there. Same thing for max material condition. You need to tell it its diameter size, the upper and lower, and if it's a through or a through hole or a post, same thing. The more material, the different size, those features are going to be on there. Concentricity. Got a funny little picture over here of good concentricity and bad concentricity. Concentricity checks to make sure that the center of one feature, typically a circle, is centered to another feature, typically a circle. This is going away, and so you'll see more true positions with 0, 0 basic dimensions, but you're still going to see it on prints. I'm sure it'll still be on prints for a while. And so this one's just making sure that those are centered. Most likely for a mating part that's going through. Again, renaming your datums when you measure that diameter that it's referencing will help you out. You'll see the concentricity tab over here. Also, you can see here, just to preview it a little bit, you'll see your line profile and your run out. Those tabs are over there. Couple things that might be able to, or that would make concentricity go out. Make sure that the tools that you're using are accurate. Make sure that you're using the F-scan lines. Make sure that you're using the F-scan circles, arcs, whatever it might be, to make sure that you're really getting the true shape of that diameter. So how we did circularity, make sure that that whole feature is being measured and the points are put across that whole surface on there. So those are just a couple of the tools that we would use real quick. Like I said, this was, advanced 2, which can go 2 to 4 hours, condensed all in one, but we wanted to give you some tips and tricks for all that. I want to talk about reporting and exporting GD&T. Here's a quick little review of setting up your exports. When you measure a feature, we renamed it, we toleranced it in the GD&T tolerance boxes. Don't forget to tell InSpec what you want to export. Remember, F2 rename, F3 is tolerance the feature, and then hit that F4 button to export. Remember, this is telling InSpec what you want to export, not when and where. So this first box will pop up, and make sure that you come down and, whatever true position that you're reporting, you want to make sure you click that. If you're getting the material modifier, make sure you click that, because true position RFS might be out, but with that bonus tolerance, it might be in. So I would hate to be able to program a whole part, run 100 parts, and just report the regardless of feature size and not get that material condition bonus. You'll see concentricity here, circularity, all the options will be there. And then after you're done with your whole program, if you go to Tools, Playback Options, here's a quick little review. And this is in your Advanced 1 book of how to set up all this stuff, and you tell it its file name. One thing that I've seen, and I'll talk about it here in a second, is the cleanest looking to me Excel file for GD&T exports is tab new line. And you'll see here in a second. But if you don't need to export to Excel and you just want to export and print out a report off the microview report, this is the cleanest looking. If you go to File, Reporting, select Standard on the drop-down menu, hit Exports Only, show Schematic, and then sort by name, and all your GD&T will be there and report and look real nice. Here's the 2 examples of exporting to Excel that I wanted to show. If you do tab new line, you see that my dimension 15-1, it gives my X basic, it gives my Y basic, and then it gives my true position and circularity all in one line. The way that we report on our inspection report is that it goes center X, center Y, diameter, circularity, true position down in the column. That's why I like tab new line, because all my data for that dimension 15-1 is straight down in the column, and I don't have to go across my long Excel file to find those features. So when we make a report like this, that if you guys send in any parts for dimensional inspection to ATI's lab, you'll get a report like this if you don't need us to fill out your standardized report. And then you can see that all my actuals are down in a line and it's not straight across on the report. And we report diameter, true position. I report my basic dimensions and all there on there. So depends on how you guys report. I know we have a couple customers that, you know, dimension 15 on all 100 parts are all in one line across, going straight across horizontally. We report vertically, whatever works for you. Just know that those options, when you go to the delimiters here, is that play around with those, find which one works for your report. Because when we export all this data, like I was saying that, you know, we want to expedite reporting time and we want to take the least amount of time reporting. We export it and we're able to copy and paste it to our Excel file with the report, and it auto drops into our report. So we're not typing any numbers, human error, you know, you hit the wrong number. You know, the less that you have to do, the more accurate your reporting is going to be. So here's a identifying GD&T review. This this table right here is in your advanced training manual. It's nice to print out and just be able to put up on, you know, next to your microview or at your desk. If you're new to GD&T or you forget what symbols are, it's just a quick little review to be able to find it real quick. This is the battle planning that I was talking about. First thing you want to do is find your datums, find any GD&T that's needed. You know, we had true position, we had circularity, we had straightness, angularity, perpendicularity, and then find all dimensions that influence that GD&T. One thing that I've talked about in previous webinars was getting, you know, multiple different color highlighters and highlighting all these. So when you're going to actually program, it's real quick to find them and you're not searching over the whole blueprint. I looked at a blueprint yesterday that had over 300 dimensions on it, and about 150 of them were basic dimensions. So highlighting all of them and getting all organized before measuring any GD&T is going to help me out in my inspection process so much. It's going to you know, speed up the process, and I'm not going to be searching for where's this basic dimension, where's this basic dimension. So it really helps out there. One thing that I want to talk about was Dan and I, the two trainers here at ATI for microview. We want to offer a custom blueprint reading to programming training. We've had a lot of customers that they're like, I know how to use the microview and I know some GD&T, but I don't know how to combine the two. So we want to come next to you and train you through of looking at your physical parts, your physical prints, and take those, find the GD&T features, and walk you through and train you how to measure it on the microview. So that's one thing. And then a little bonus on there is any program that we write while we're training, because it's your parts, your prints, and you'll be able to save it and go on from there. And then also with a lot of people working from home, and also, you know, some of the restrictions of not being able to have visitors into your facilities, we're also doing webinar training just like this, but it's just you and your team. We can do the basic and advanced training via WebEx. We like to use WebEx because we're able to record these. We're able to record these webinars, and then we'll actually be able to, your training class, we'll be able to send you the link via Dropbox to be able to view the training class later. And also training classes can be customized to your team's needs. If your team's been through basic and advanced training, but is, you know, having difficulty with using a touch probe or the rotary, and you guys, you know, want some more training on that, let's figure it out. And then, you know, as I always say, here's the contacts for us. Any microview support and additional training, email us at training@ATI. Inspection, if you guys have some parts that, like I said, profile, or if you don't have touch probe and you need a feature measure on touch probe, email inspection and give us the prints, and we'll be able to help you guys out there. And another thing is that if you weren't here while the slides before the webinar started, expect an email from me. I'm going to send out an email that has a survey link to it. It takes 2 minutes. It'll help me, Dan, and the rest of the team here out of creating these webinars that more benefit you and your team. And then also just, you know, how the timing is going, just a couple of questions that will help us out with your webinars. And then also a link on there to register for next month's webinar. I got that open already. We're going to just talk about simple tips and tricks to expedite your inspection process and get your programming faster. You know, little tips and tricks that could speed up, you know, take a half-hour program, bring it down to 15 minutes, which, you know, everybody would love, because then you're measuring more parts and getting more through the door, more product through the door. So, again, if there's any questions, throw them in the chat box as we're finishing up here. We'll be able to follow up with you. Email training@ATI Quality, or Dustin or Dan at ATI Quality with any complicated GD&T questions. We want to do these webinars to spark conversations with you guys, you know, help you guys out with your prints, with your parts, get more better at your skills of microview inspect usage. And there's some features in there that, you know, hopefully it sparks some questions today that you want to learn more about. So feel free to email us and get in contact with us. Me and Dan are going to stay on here for the next 5 to 7 minutes and able to answer any questions that pop into there. And I just saw in the chat box, we're looking into making a YouTube channel of just little tips and tricks onto there. So be looking out for that. We'll probably talk about it on next month's webinar. Just little things that we come across that we don't realize that we're using every day that could be helpful for all of you guys. So thanks for joining another Microview Inspect webinar with us. And we'll see you guys next week, or next month actually. All right, thanks guys.